So this is simply a balancing equation problem. And what we need to report is the coefficient in front of O there. So remember how we do this. Start with the non-H and O's. That means there's got to be a 6 there. And then we look at the one next between H and O that's in the fewest number of compounds. And that's H, and so that's 14 here. We got to have a 7 in front of that to make that 14. Now we add up our O's. So we have 12 O's from the CO2 plus 7 O's from the water. And that's going to give us a total of 19 O's we have to count for. Remember, we already have 1 O there, so we're really looking for 18 O's. And the way you can do that is by putting a big fat 9 right there, and that gives me 18 O's. So for question number 25 here, or chapter 8, question number 27, so we're given this reaction, calcium oxide plus water gives calcium hydroxide. And we have a 5-gram sample is reacted with 4.83 grams of water. How many grams of water remain? So again, if water remains, the limiting reactant must be calcium hydroxide. I'm going to do this a little bit different, okay? I'm going to, and we can do it the same way, figure out how much calcium hydroxide we form from the 5 grams, go backwards and find out then how much H2O is consumed. But what I really want to know, right, are the grams of H2O that correspond to 5.0 grams of calcium oxide. So that's what I'm going to calculate just directly. To consume this, it's in this ratio. It's got to be, let's make sure we're balanced first. And we are, right? You balance 1, 1, 1. And for every 1 mole of this, we use 1 mole of this. And so there's a stoichiometric relationship between these two. And let's just use that then to calculate how much water is consumed while we're using this 5.0 grams of calcium hydroxide out. So we have to cancel grams of calcium oxide, make it into moles of calcium oxide, because that's a stoichiometric ratio, and we'll figure out what that mass is in a minute. Now we've got to get rid of moles of calcium oxide and make that moles of water, and that's a 1-to-1 ratio. And then we need to, and that cancels those units, and then we need to get rid of moles H2O. That cancels with that, and we put in grams of H2O, and that's 18 there. Now calcium oxide, and that turns out to be over here. That is 56.08, and then and what I find out here is that this becomes 1.6 grams of H2O. So here's what it's saying, is that to consume this 5 grams, it takes 1.6 grams of H2O. So if we start with 4.83 grams of H2O, we consume 1.6 grams of H2O. That 3.23, and Cinema Figure says it's 3.22. Okay, and that's 25. So those are the ones out of Chapter 8, and I'll put those up online.